Hi everybody. So in this video, I'm going to show how to code the Heston model. And what the Heston model does is it simulates stock prices and option prices to get like a good picture of what the future price will be. And it includes two stochastic differential equations. The first one to model the stock price, and then the second one to model the volatility. So what we're going to do first is build the volatility function with the parameters kappa, theta, and sigma. So in order to do that, I have some historical data loaded from Polygon. So what I'm going to do is I'm going to define a ticker. So ticker equals, let's do, what stock should we do? All right, I'm just going to do Apple. So then I'm going to fetch the data. So I'll call this response equals get ticker. And I'm going to print the response variable, so cout response end line. So now I'm going to come here and compile it. So g++ heston.cpp, C++14, and lcurl for the REST requests. And this is the first terminal, so it's going to take a little bit. Like, I don't know why my Mac just goes through all of the compiling libraries and then finally executes it. But yeah, we'll just wait a little bit. Okay, so now I'm going to do /a.out, and this is the historical data. So what I want to pull is I want to pull the results list, and I want to specifically pull the C key, which is close price key. So in order to do that, I'm going to first, so I have boost property tree declared here and imported. So I'm going to do ptree JSON, and it takes an argument of a response. So this will be std string stream ss of response, ptree result, and then read JSON of ss result and return result. Okay, so we got the JSON function. Now in order to get these, we need to define another function that's going to loop through it. So I'm going to first come here and declare a vector called prices. And then I'm going to come here and create a function called typhoon. And it's going to take the argument of a data set and a ptree, it's going to take a vector of prices. And they're going to be variables, so they're going to change in this function. And then I'm going to include a boolean called results. That's to see if like it has parsed this key. And then, so I'm going to come here, and now I'm going to do for ptree const iterator it equals df.begin. It is not equal to df.end plus it. So if the first key equals results, it's going to do a recursion. So that'll be it second. std reference prices and true. Okay, so now if results equals true, that's when we have this whole data set in here. I'm going to define for ptree const iterator jt equals it second dot begin. jt is not equal to it second dot end plus jt. So now we want to pull the close prices with the C, so it's going to be prices dot pushback of jt sec. Oh wait, I have to do if jt first equals C, we will do prices dot pushback jt second dot get value of double. And then yeah, we'll have our price vector. So I'm going to minimize this one. So now I'm going to come here and do typhoon is JSON of response, and I will do std ref prices, and I will put false because it hasn't fetched the result key yet. So now I'm going to just print out the last stock price, so prices of prices dot size minus 1. So now I'm going to come here and compile it again. Reset ./a.out. $189.98. Okay, so let's check Apple's price. So Apple stock price, $189.98. Okay, good. Okay, so now we've got all the data. Now we can compute the parameters. So I'm going to call this function vector double. I'm going to call it computer, and it's going to take a vector of prices. So I'm going to define the result vector, so that's double result, and then return result. But what I'm going to do now is create some lambda function, so I'm going to call this mean equals vector double x. Let me make sure to close this off. So I'm going to do double total equals 0, and then for auto I in x, total plus equals I, and then return total divided by cast double x dot size. So I'm going to minimize this function now. So the next function I have to do is the variance function. So it's going to be auto variance equals vector double x. And let me make sure to close this off as well. So now I'll do the same thing. Double total equals 0. Double mu equals mean of x. So we need to add an and symbol in this since we're inheriting a function. And then for auto I in x, it's going to be total plus equals the power of I minus mu squared. And then it's going to return total divided by cast double of x dot size minus 1. So yeah, let's close this off now. So I'm gonna declare some more vectors up here. So I'm gonna do sim vol for the volatility, and I'm going to do ROR for the rate of return, and I'm gonna start with ROR. So I'm gonna do for int I equals 1, I is less than prices dot size plus I. So this is going to be ROR dot pushback of prices I divided by prices I minus 1 minus 1.0, and then I need to find the drift, so that's going to be the mean of ROR, and I need the stock price, so double price equals prices of prices dot size minus 1. So I have the stock price, I have the drift, now I have to compute theta. So I'm going to define a window and set it equal to 75 days. And then I'm going to do for int I equals 0. Int I equals window. I is less than ROR.size plus I. So I'm going to create a vector in here called hold. And it's going to hold the window, the rolling window for the rate of returns. So ROR.begin plus I minus window, ROR.begin plus I, close that off, and then I'm going to do double, I'll call it vol equals variance of hold, and sim, is that what he called it here? Yeah, sim vol dot pushback vol. Okay, so now that we have these, we could do, so double theta equals, so I will do square root of mean of sim vol, and then I'll do double sigma, which equals the square root of the variance of sim vol. And then for the kappa, I have to declare top equals 0 and bottom equals 0. And I'm going to do for int I equals 1. I is less than simvol.size plus I. So top is going to be plus equals simvol of I minus, oh wait, I have to also do double mu vol equals mean of volatility, so simvol. So that's going to be mu vol times sim vol of I minus 1 minus mu vol. And then the bottom is going to be plus equals the power of sim vol of I minus mu vol squared. And then the kappa, so kappa will equal negative log of top divided by bottom divided by delta time. So I actually have to include delta time in this function, so I'll do double delta time. And now that I have all these parameters, I have to do result equals kappa, theta, sigma, price, and drift. Okay, so now we can minimize this function. So I'm going to call this over here. I'm going to do, so first let me declare time equals 30 days, and then steps is, simulation steps is going to equal 1,500. Paths is going to equal 150 paths. Simulations, I mean. So then I'm going to do double dt equals t divided by cast double n. Okay, so now I have the prices and everything. I'm going to do std vector double params equals computer of prices and delta time. So now let me go ahead and print these out. So for auto and u in params, I'm going to do std cout u and then end that line. So now let me come here and compile the code. Okay, good, there's no errors, and I'm going to do /a.out. Okay, so this is our sigma. No, this is our kappa, this is our theta, this is our sigma, this is the stock price, and this is the drift. Okay, so these look like pretty small numbers. Let me actually change it. Instead of 75 days, I'm going to set it to 50 days. So now I will compile it. Did I take a square root of the sigma? Oh yeah, I did. But it's just such a small value. Okay, yeah, whatever. We'll just deal with it. So yeah, let me go ahead and minimize this function now. So I'm going to take this out. So now for the equations, so the simulation will first be for int I equals 0, I is less than p plus I, and then this is going to be double s0 equals params of 3, and double v0 equals 0.3. So now I'm going to do for int j equals 0, j is less than n plus j. So I need to define a function up here called dwt, so double dwt, and then I'm going to do int num equals 10. So this is going to return a value between negative 10 to 10%. So it's going to be double dw equals rand mod 2 times num plus 1 minus num, and then we're going to return dw divided by 100.0. So that's our random component to the stochastic volatility model. And what I'm going to do here is set the seeds. So it's going to be srand time null. And then in the simulation, I'm going to do double dw equals dwt, and then I'm going to do volatility 0 plus equals kappa. So yeah, kappa times theta minus volatility dt, and then sigma square root of volatility dwt. So it's going to be param 0 times params 1 for theta minus volatility times delta time plus params 2 times the square root of v0 times dw, and the stock price is going to be plus equals params 4 for the drift times the stock price times delta time. Let me just make sure that's right. Yeah, drift times stock price times delta time, then square root times stock price times that. Okay. So plus square root of v0 times stock 0 times dw. So now I'm going to declare another variable called here. I'm going to call it forecast price and set it equal to 0. So here I'm going to do forecast price equals plus equals stock price, and then down here I'm going to do forecast price divided by equal cast double p. So now I'm going to print out params 3 for the current stock price, and I'm going to print out forecast price and then end that. So now I'm going to come here, compile it again, reset, ./a.out. Okay, so it's generating some results. Okay, so I got seg faulted. I placed too many REST requests. So in the meantime for that, I'm going to actually build a simulation now. So I'm going to do, so I got to make these all go here. So I'm going to do for int k equals 0. K is less than 1,000. No, 100 plus k. So I'm going to come here and do, so I'm going to define two integers. So I'm going to do int long, no, I'm going to call it go long equals 0 and go short equals 0. So it's going to be if params 3, the current stock price is less than or equal to forecast price, we are going to go long, so go long plus equals 1, versus if we're going to, if it's greater than the simulated price, we're going to do go short plus equals 1. And now I'm going to come down here for the last portion, and I'm going to print out long short ratio. No, I'm going to do long. So go long, and then I'm going to do short. It's going to say go short, and I'm going to do current stock price, and that's params 3. Okay, so let's run this again. Okay, so I'm gonna do ./a.out. Okay, so 61% of it is saying go long, 39% of it is saying go short, and the current stock price is $189.98. Let's run a couple more of these. So now that everything's done with the actual model, I could just run this. So 56 to 44, 67 to 33. Okay, so this is sort of neck and neck. It could go either way. It's favoring that it's going to go up, but actually, let's do something else now. Let's actually print out another stock. Like we have the ticker up here. So this time I'm going to do I'll do Nvidia. Let's see how this fares. So I'm going to come here and compile it. Reset. So ./a.out. 100% going long. Okay, that's a good bet. 100% again. 100 again. Okay, so that one seems pretty set. Let's do a stock like Amazon. Let's see what it says for that. So I'm going to reset this and then A.out. 76% chance long, 24% chance short. Okay. 78, 20, 20, 22. 78, 22. Okay. And then at rate limited. So, okay, I'm going to leave this at this. This is the Heston model, and this is how it runs when you code it out in C++, and it requires like some historical data to like compute the parameters and stuff. But I hope y'all enjoyed watching this video. I thank you for watching it, and I'm going to be coming out with more good content. And also, if you haven't joined the Discord chat yet, please make sure to join that. But yeah, thank you. Peace out.